All right, this is Guided Practice 13. This is section 7.4, integration by partial fractions. So this is when we're integrating something with a fraction. Notice that the first thing I look at is I look at the fact that the degree on top is less than the degree on the bottom. So I don't have to divide anything through. I can start by looking at, can I factor the denominator? So the first thing I'm going to do is I'm going to go ahead and factor out an x. So this is the integral of 2x squared minus x plus 4 all over x times x squared plus 4 dx. And so I want to be able to separate this into two partial fractions by making this the integral of something over x plus the integral of something over x squared plus 4. And I want those two things to be equal. X is a linear term, so what I write above that is just an a, right? And I'll have to figure out what that a is, some kind of constant. And above the quadratic, because I can't reduce that any further, I have to put something that is a linear factor. And so what I want there is bx plus c, okay? And I want these two things to be equal. So let me go down here and kind of sort it out and find my a's, b's, and c's. So we have a over x plus bx plus c over x squared plus 4 has to be equal to the original one, which was 2x squared minus x plus 4 over x times x squared plus 4. Okay, so in order to solve this, we want to clear out the denominator, so multiply everything by x times x squared plus 4. And when you do that, you cancel out the x in the first term, and so you have, whoa, sorry about that. There we are. You will have the x's cancel, and we will have a times x squared plus 4. The middle one, when you distribute, that will cancel out the x squared plus 4, and you will have bx plus c times an x. And that has to be equal to what's on the right-hand side, and the denominator totally cancels on the right-hand side, and you get 2x squared minus x plus 4. Okay, so what I'm going to do here is I don't have a good way of finding a, b's, and c's because they're not all linear. So I'm going to multiply this all out and equate coefficients. So we're going to have a x squared plus 4a. And we're going to have bx squared plus cx has to be 2x squared minus x plus 4. Okay, I want to equate my coefficients. So I'm looking for x squareds. I have an ax squared plus a bx squared, and that has to be equal to 2x squared. So that tells me that a plus b has to be 2. And the reason for that is because ax squared plus bx squared has to be 2x squared, right? Well, if you divide 3 by x squared, you get a plus b equals 2. So that's the first thing that I know. So I know this one. Then I do the same thing with the next term. So I have a constant term, or sorry, an x term that has to be equal to this x term. So that tells me that the coefficients have to be equal. So cx has to be equal to negative x, or c has to be negative 1. So there's one of my values. And then lastly, I have a constant term for a that has to be equal to 4. And so I will have that 4a equals 4. And if you divide 3 by 4, you get a is equal to 1. That gives me the a. Now that I know the a, I can bring it back all the way to the left here and plug it in. So I'll have 1 plus b equals 2. And when you subtract over the 1, you have that b equals 1. So now I've found my a, b, and c. So what I'm going to do is bring those back over. So a and b are both positive 1, and c is negative 1. So that means I'm going to have the integral of 1 over x plus x minus 1 over x squared plus 4 dx. Okay, what's next? Let's try to integrate this. Well, I know that I can integrate the first piece, no problem. The 1 over x is totally fine. But this next one, if I were to try to u sub for the denominator, for the x squared plus 4, that's going to be, the derivative of that is going to be 2x. And I've got more than 2x going on up top. So I can't use just straight u sub here. So I'm going to want to split this. So I'm going to make it x over x squared plus 4. And I can split numerators. Remember, I can't split denominators, but I can split numerators. And now I have three pieces, each of which I know how to handle. So the first one, the antiderivative of 1 over x is ln of x. Good to go. This last one over here is an arcsine, right? Well, kind of. Let's see. Is it going to be arcsine? It kind of looks like arcsine, but it's really a, sorry, not arcsine, arctangent. It's almost an arctangent, but we're going to do a trig sub on that one. So in the middle one, we're going to do a u sub. So actually, let me bring this down a little bit. Let's see if I can do all my subbing in here. So for the middle one, we're going to let xu equal x squared plus 4. And then du is 2x dx. And the x dx is 1/2 du. So that when I make that u sub, I have the integral of 1 over u times 1/2 du, and that 1/2 can come out front, and we'll deal with that in the next one. Over here, this is a trig sub. So our x is going to be 2 tangent theta. Dx is 2 secant squared theta, d theta. And we're good to go. So when I go ahead and make that substitution, I get the, minus the integral. And I'm going to have 2, that is the integral of 1 over 4 tangent squared theta plus 4 in the denominator. And my dx is 2 secant squared theta d theta. Okay, let's clean them up in the next step. So this is the natural log of absolute value of x. That one's all done. And this is 1/2 integral of 1 over u du. And this one is going to be negative. Let's bring the numbers out front. I can factor a 4 out of the bottom. So I'm going to have 2 over 4, or 1/2, the integral of secant squared theta over tangent squared theta plus 1 d theta. And all right, we got the natural log, absolute value of x, plus 1/2 natural log of u, absolute value of u. And over here, I'm going to have negative 1/2 integral of secant squared theta over secant squared theta, d theta. So that actually cancels out nicely for us. And that's going to give me the natural log of absolute value of x plus the 1/2 the natural log of u minus 1/2, and this becomes the integral of 1 d theta, which is just theta, plus a constant. So now I want to sub back. So this is the natural log of absolute value of x plus 1/2 the natural log of u was x squared plus 4. Minus 1/2, and my theta, I'm going to here. Let's see, x over 2 is tangent theta. And then theta is the arctan of x over 2. So we get 1/2 the arctan of x over 2. So it is an arctan, it's just adjusted a little bit. Okay, and that is our final answer.